One of the least appreciated areas of physics is actually optics, particularly lenses and mirrors. I mean, for a long time it was only thought that, well, it was thought that lenses and mirrors were only useful in things like telescopes and microscopes and things, and glasses, opticals. And then people realised actually you can apply optics to a whole lot of new areas that they'd never actually thought of before. So nowadays optics turns up in quite unexpected places. So we're going to be looking at two things. We're going to be looking at ray diagrams, and then we'll look at the equations. So with ray diagrams work are a pictorial way of demonstrating something, because humans see pictures a lot better. And they work by light travels in a straight line. And because of that, we can makes it quite easy to draw these as long as you have the assistance of a piece of equipment called a ruler. Now, very similar with lenses and mirrors, the same basic principle applies. So what we do is we draw in a neutral axis, and that's what we call our zero line. That's where we're going to measure everything from. And then what I call it line of action, which is at right angles. And then we're going to draw in our optical element, and usually we've got a choice of 4 optical elements that we look at. We look at concave mirror, concave, and that's a mirror. We look at a convex mirror, and the fur tells us which side's opaque. But we also look at lenses, convex lens, and concave. And those are the 4 basic optical elements we're looking at. There's also planar mirror, which is just a flat mirror, but we're not going to worry about that at the moment. We're going to look at these 4 in particular in the next few videos. Concave, convex, convex lens, concave lens. And what we do is we draw whatever our optical element is on here. This just tells us what we're dealing with. Then we're doing ray diagrams. We'll need a few pieces of information. We'll need a focal length. If it's a mirror, we just have 1 focal point. If it's a lens, we have 2 focal points, same length. And that's going to be F for focal length. And we're going to need an object. And the object we usually just represent by an arrow. It's got direction, it's really easy. So when we're drawing ray diagrams, if we're drawing mirrors, there's 2 lines. So for mirrors, we draw in 2 or 3 lines, depending whether it's a mirror. So the first one is going to be parallel, then through F. So what I mean by here is we grab our ruler and we draw a line parallel to this line. And then, where it goes from there, we will draw it through, this is also F, through F. And that's going to be our first line. So this is line number 1. Now line number 2 is through F, then parallel. And the way we draw the line through F is we grab the ruler. And this is actually, once you get this is a simple concept. We put one end of the ruler at the tip of the arrow and the other end, and another part of the ruler on that F. That F, the same F was on that side. And so we're putting it through this F, not that F. We do that for special occasions. So we put the mirror so it touches there and there. And then we draw the line down to our line of action. Notice I'm not really worried about the lens shape here, I just draw it to the line of action. Then I will draw it parallel. So once it hits this line of action, then it goes parallel. So this is parallel. So it goes down here and along here. And if you're doing lenses, so this is good for mirrors and lenses, but if you're doing lenses, there's a third line that you can use. Lenses, from the object through the centre. You can do something similar with mirrors, it just tends to be way too much effort. So for the third line, I will put the ruler at the tip of the object. I will put it through the centre where those two lines cross. Now if I've done this well, then they should all pretty much meet at this point. And where the lines cross, that's where we're going to put the image. And there's a couple of distances on here that we call, so this is the object. So the distance from the object to this line of action is distance object. This is going to be the image, and the distance here is going to be distance image. So this is the image. So there tends to be three important bits we end up with. We end up with the focal length, the distance from the object to the line of action, to the lens, and the distance from the line of action to the image. So we'll actually go through all of the cases for a concave mirror, convex lens, and then a concave lens in a second. But we'll just do the math. So when you're doing this for mirrors, parallel through the focal point. Second one, through the focal point, parallel. If you're doing lenses, you can also stick one right through the centre. In reality, you only need to know two of those lines, and because they all meet at the same place, you can just do two of them. Your pick, your choice, whichever you find easiest. So we'll do the math of this in a second.